All right, so my name is Ben Mushko. I also work for Gradle Inc. And today I want to talk about Gradle plugin best practices. So this is pretty much a talk about lessons learned from writing plugins over the years. So some of you guys might know some of my plugins. Anybody used my plugins? All right, yes. Which one? Tomcat. Okay, fair enough. Good, awesome. So I want to talk about best practices and techniques that I personally learned from writing these plugins, and that obviously changed over time. And of course, we share the same kind of values in the Gradle core team. So some of the things are more my personal opinion, I guess. Some of them are pretty much public knowledge, I guess. So this is not going to be an intro talk to Gradle plugin development at all. So if you're interested in that kind of stuff, I highly recommend that new training that we have on Gradle.org training. It's about writing plugins, extending the DSL that we have in Gradle. So if you want to learn about that kind of stuff, that would be the perfect start. It's pretty much a one-day training, so we split it up into 2 half days, so you can get started pretty quickly. So this talk is actually going to be 1.5 hours long. So I compressed this one a little bit. So if you want to see some demos and additional kind of like information about advanced topics, I'm also going to cover that at Spring 1 if you want to come there. Otherwise, I can provide you with code examples and so on a bit later. This talk will be example driven. So we'll pick a plugin that we'll dissect, that we'll have a look at. So we'll show you examples for some of these techniques that I'm talking about. So before we actually dive into best practices and techniques, and I'll show you some code examples, I actually wanted to take a step back and think about why we actually want to write plugins. Why do we want to abstract certain logic? Why don't we just dump everything in to a build.gradle file as we maybe were used to in AND or something else? And there are good reasons for it. You can see here we have the grumpy Gradle fan. That's the unhappy elephant. About builds that we used to work on, and hopefully now it's better for you guys. But let's pick some of these arguments for wanting to have a better build. So first of all, if you don't abstract your logic in a certain kind of way, and plugins is just one concept for doing that, you have unstructured spaghetti code. It grows over time. It's not maintainable, so you're getting kind of crazy over time. And once you get to a point that you find something useful, you work not only on one project, you usually work on multiple projects in parallel potentially. You want to reuse certain logic. So you want to take logic, have it in another project. It should work the same kind of way, but what happens if it changes in one place? You have to make a change, and you also want to have it in another place. So you're starting the copy-paste game. Certainly don't recommend doing that. Both of these arguments here, that I mentioned, usually lead to a pretty much unmaintainable build, which can oftentimes only understood by one person. That person is usually assigned, that poor person, or somebody that actually likes doing that kind of stuff. And that's usually the build guru. Everybody comes to that guy, asks questions. All the other guys don't know what the hell is going on. They just run a task or a goal or a target. That's what they do. They're done. And obviously that's kind of bad because we want to distribute knowledge and we don't want just one person working on the build. Oftentimes what you also find, the build tools basically control how you should structure your code. If you have some legacy application that doesn't stick to these conventions, that's obviously bad, so it makes your life pretty hard. And we want to avoid that. We as Gradle understand that. We always let you configure certain conventions that we provide. And we'll talk about some concepts here as well when we get to the concept of convention over configuration and these kinds of things. And of course, when we talk about build logic, that shouldn't be different from application code. It should be testable, so we should be able to write tests on different levels, not only just some integration tests, but also some unit tests, functional tests, integration tests, of course. And potentially, if we're talking about just a build in a regular or for a regular application, we might be talking about smoke testing, performance tests, and so So in this talk, I will actually mainly focus on functional testing, and we'll talk about the new Gradle test kit that we have with 2.6. So that's going to be exciting. So if we look at all these arguments, we certainly find that we have typical non-functional requirements in builds. That not only applies to application code, but we can see that some requirements that we know from application code also applies to the build world. And I want to talk about some of them here: reusability, testability, maintainability, extensibility, configurability. Of course, you can probably name 5 more if you wanted to, but these are the ones that I'm going to focus on. And they are pretty much important for me personally. So let's talk briefly about each of these points here. So reusability, of course, we want to avoid copy-pasting code. We want to be able to abstract the logic, bundle it, publish it, make it available to other people. So we can easily share that logic and configure it from the outside. Testability, I already mentioned, we want to be able to test build code on multiple levels, not just on a unit test level or something else. And of course, we also don't want to test it manually. That's the worst part. So we don't just want to run the build and see if something works that are changed. Maintainability, same software development practices hold true here. So we want to avoid a big ball of mud of some code that's like unstructured. So cohesion, separation of concerns, still important. Of course, other practices that you might know, design patterns. And we actually allow you, when you write plugins, to abstract it nicely into classes, methods, packages, and so forth. Extensibility. So once we write a plugin, we don't just want to throw it over the fence. We want to integrate that in the existing Gradle core DSL that you might already know. So we want to be able to expose our own domain-specific language on top of the Gradle core DSL, and potentially also expose new methods, new properties that are usually attached to the domain model. So you don't want to have free-hanging, freestanding kind of like properties and methods. And of course, once we get to a point that we have certain conventions for plugins, for example, deployment points to a specific server, we want to make this configurable. So pretty much everything should be configurable if possible. So we don't want to box in the users. We want to make it configurable through properties, methods, and potentially even a custom DSL, which makes it more readable for humans. And I think it's nicely structured usually. So these are kind of like the points that I also want to pin back when we talk about plugins and certain concepts, techniques that we have. So what should be the end goal? We see the build happiness bird here. So the end result should be a maintainable, reusable, and tested code. And I think it's obvious why we want to have that. It results in less bugs. If you have to refactor something, you know exactly that it's tested. Everything should be good, so you can easily push it out. So that's what we want to achieve. The consumers of your plugins and your build logic in general shouldn't be bothered actually a lot with complex logic that should be completely abstracted, hidden in plugins or tasks. The only thing we want to give them is something like a DSL where they just say, okay, I want to configure this thing, but how it happens under the covers, how this works, I don't really care, as long as it works actually for me. So how do we get here? So these requirements can be implemented with a bunch of concepts here. Of course, good software engineering practices, pretty important. So that's completely independent of Gradle, but Gradle acts as an enabler here. Custom tasks, so we can hide away certain logic plugins on a higher level. Gradle's extension mechanism, which allows you to introduce new custom DSLs. It allows you to attach new properties to the already existing Gradle core API, and also methods, of course. And testing capabilities, that's something that I will talk about for a couple of slides, because I think it's important, it's personally important to me that I make my build code testable as well. And we'll mainly talk about the Gradle test kit. It's, by the way, sponsored by Netflix, so a big shout out to them. I know the Gradle community really wanted this feature, so we're pretty happy as Gradle Inc. that we finally could get started on that feature, and we'll talk about how to use it, how to write a sample functional test in this talk as well. So some of the techniques that I want to cover in this talk, and in the longer version of this talk, there will be more. There we'll actually also talk about continuous integration and delivery, how to work your way towards that. Declarative versus imperative logic, what's the difference? And how do you make it happen in your build? Convention over configuration, I think that's a pretty common concept known to pretty much everybody, hopefully. Capabilities versus conventions. So what's the difference between the base functionality, a new concept that you might want to introduce with a plugin or with a task or something else, versus the conventions, so certain sensible defaults that you might use to pre-configure or instantiate these concepts. Testing plugin logic, already mentioned that. And I also want to talk a little bit about writing and generating documentation. I think that's something that we all don't necessarily like, but it's important, especially for consumers of plugins, because we cannot necessarily auto-document plugin logic that we inject into a project. This is something that we might want to explore in the future. I think that would actually be pretty cool if the plugin or some report, like the dependency report just for plugins or components, would say, well, if I apply this plugin, I get these tasks from this plugin, I get these dependencies, these extensions, this is how you configure it, and so forth. So I want to talk about a specific example here that I want to pick. It's the Gradle Docker plugin, which you can have a look at on GitHub. So all the examples that I will show you here on the slides will be in the repo here. So you can always go back. You don't necessarily have to understand what Docker is. If you never used it, fine. Doesn't really matter. We are not talking about the functional piece of this plugin. We mainly talk about the Gradle pieces that are important in specific concepts. But on a high level, what it does, it allows you to create and manage images and containers through the Docker Remote API. So obviously, there have to be HTTP or HTTPS calls to Docker. So we have to hide this logic in the plugin. Completely written in Groovy. Of course, you could write this in Java as well or any other JVM language if you wanted so. So let's talk about some of these techniques. Hiding complex imperative logic, I already mentioned. We don't want to bother the consumers of our plugins with any complex logic. For example, if you go back to a Docker plugin, we don't necessarily need to know how we do the HTTP communication. So that should be hidden in the plugin, in the tasks, completely abstracted. That leads to reusable and configurable code, I think. It's far easier to structure it because you can break it down into pieces. You can write classes that do the HTTP communication. In fact, for this plugin, I actually also use an external library, Docker Java. So I don't actually need to do this myself either. So that's also kind of hidden from me. I just upgrade if they have a new version of it. That makes your code easy to refactor, easy to be tested. So I think that's kind of important. And generally speaking, I would say avoid creating some sort of global properties or methods in your build that you reference in some subproject. That's usually, I would say, considered a bad practice. And we learned that from Ant, where we have some property in some root project, and then like somewhere down 3 nested levels, we use it, and we don't know where it's coming from or what actually creates it. So I would usually say, if you need properties, if you need methods, attach them to the domain object. And a domain object could be a project instance, a task instance, these kinds of things, or like the dependency handler even. So let's have a look at a custom task. So this concept applies to custom tasks. So imperative logic can be hidden in custom tasks. And here's a good example for that in the context of the Docker plugin. So here we see in the example 2 tasks. They both use a type. The first one creates a Docker file. And the only thing we actually say as users, we just say, well, this should be the file we are creating, the destination file. And then we add a bunch of instructions that should be written to that specific Docker file. So if you're not familiar with the Docker file, it's just a file that has n instructions, and there are different types of instructions like from, maintainer. And you can actually see I exposed methods here as well. From and maintainer are methods that I expose from my custom task Docker file. So this almost becomes readable, like my own DSL almost. We don't know exactly how this is actually generated. This is happening under the covers in the Docker file task. And then we can also have another one here, build Docker image, so creating an actual image from the Docker file. Also completely hidden. The only thing we actually have to say, this is the tag for the image that I want to produce. And please point me to the input directory that has the Docker file. And before we do that, we can depend on the other task, so we make sure it's actually created beforehand. But you get an idea that we don't even know how this is happening under the covers. This is how you want to completely abstract it. I also mentioned there ad hoc tasks. So if you want to create one-off logic in your build script, that's great, but usually you should go for custom tasks. Sooner or later, we want to reuse certain logic. And I find myself even like almost starting with the custom task implementation right away, except if I just want to do something very simple, one-off kind of thing. So prefer task types over ad hoc tasks because they're just more reusable. Oftentimes you see people using script plugins a lot, especially referring to them over HTTP. I would usually say don't do that because they're not cached. So with every invocation of your build, we make the HTTP call. If it's not accessible, well, your build fails. You cannot produce your artifacts anymore. Pretty bad. What I use script plugins for usually is to break down the build logic in my build.gradle file on a functional boundary. For example, here we say I have a build file which holds my dependencies, so there are apparently common dependencies that are defined for my build. Then I have individual build files for functional testing, integration testing, documentation, release. So that's a good way to break down the logic within one project. If you wanted to share this logic, then again, go ahead and try to abstract it into a binary plugin, which can be bundled into a jar file and published to a binary repo and shared among projects. But within one project, this is a good way to do things. Convention over configuration. So we want to provide our users with sensible defaults. They shouldn't just pick values for any property that you expose. Try to be reasonable here. And that's what we usually call conventions here. Standards that we set for the end user. Typical examples, the Java plugin picks source main Java as the default, sensible default for looking for Java source code for compilation. Another example could be that the project name is derived of the directory name that holds your build.gradle file. Or by default, we use build as the output directory for every project. Of course, each of these things should be configurable. So we don't want to box you in and say, well, Maven, this is like my source main Java. We make it really hard for you to change that, even though you can change it, but it's kind of like cumbersome to do that. Conventions I already mentioned. Try to pick sensible defaults, and I believe what I've seen in the field is that the less people actually have to change these defaults, the better you picked these sensible defaults. So if you find that people like your defaults, that's good. They usually don't reconfigure stuff a lot. If they do, then maybe you should think about the defaults again. And configuration, of course, is important because oftentimes you actually deal with, let's say, legacy projects. You have to migrate older projects, and their standards are usually not there, or they are there in a certain kind of way, but they are not industry standards or the standards that you might have in your organization. So make it configurable. And we do that by a lot of these Gradle core plugins. You can have a look at all these properties and methods exposed. Have a look at the DSL guide, Java docs. That's a good way to explore. So I want to give you one example for a custom DSL as well. And here's the custom DSL, or a portion of it, for my plugin for Docker. So you can see we have an extension which is called Docker. And then we can reconfigure certain things, the URL, the path that points to the certificates. If you're using HTTPS, But again, we don't even know what's happening under the covers. So obviously there's some HTTP communication going on. But we as a user, we just say what we want to change. If we like the defaults, we don't even have to change it. But the actual how is completely hidden in the plugin. So the runtime behavior is just tweaked by us, by the consumers. And of course, if you write such a DSL, you can have multiple nested levels, which makes it nice to read. So it takes a little bit practice, I think, to find the right balance again between these configuration blocks, but you will certainly get there over time. So what are capabilities? I already mentioned there's a difference between capabilities and conventions too. Capabilities usually is base functionality, like the source set in the Java base plugin, which is usually not pre-configured for you, except if you're applying the Java plugin. So try to separate capabilities from conventions, strike the right balance, because if the world doesn't look like you intended to look for the consumer of your plugin, then you still want to give them the chance to actually just use the plain concepts and pre-configure them yourself or create instances of them if they need to. We have the same concept in my plugin as well. And usually when we talk about capabilities, they are usually fairly unopinionated, like the source set concept. It's just a construct. We don't necessarily say, well, source main Java. That's actually coming from the Java plugin and not the Java base plugin. Conventions, usually opinionated. So here we say exactly, well, if you're dealing with a Java project, this is how we imagine this to look like. But again, make it configurable. Examples are standardized directory layouts, so source main Java, source main resources, where do we find the tests, where is it being copied, these kinds of things. So how do we actually make this happen in Gradle Core? So there's usually two different plugins. So we ship two different plugins. One is the so-called capability plugin. It just gives you the concept. Some people also call it a base plugin. And then on top of that, we put the convention plugin, which basically just uses the concept and pre-configures it or creates instances of tasks of specific types. So you can do the same thing in your own plugins in case people want to fall back to the just base conventions. So let's have a look at my Docker plugin, how I do it there. So there are two different plugins, the Docker Remote API plugin, just responsible for getting the right dependency for the HTTP communication for Docker Java. And it also provides pretty much a custom task for all operations that you know from Docker. That's all it does. It doesn't even create any instances for you. It picks some defaults for task properties, but that's not necessarily always the case. And then on top of that, we have a very opinionated plugin at the moment. There could be multiple actually, which is called the Docker Java application. So if you're writing a Java application, standalone application that should be bundled into a Docker image, that's the way to go. If you have a Node.js application, this is completely useless to you. So very opinionated here. It allows you to create and push Docker images just for Java applications. But internally what it does, it actually applies the Remote API plugin and then configures these tasks or creates instances of them for you out of the box so you don't actually have to deal with it. But if you just want to do Docker Remote API communication, you can always fall back to the base plugin. So that's pretty convenient. So find the right use cases for people. And as I mentioned, there might actually be multiple. So there might be a JavaScript-based kind of like application plugin or something else, depending on what you need. So how do we make this happen? It's a concept we call plugin composition. So you can apply a plugin from another plugin by either type or identifier. I always find the type to be a little bit more convenient because you actually refer to a class. And once you refactor something, this is done by the IDE automatically for you. So here we can see instead of using the actual identifier here, I refer to the Docker Remote API plugin as the actual type. So now if we apply plugins from other plugins, again, that creates certain opinions, I would say. So we should anticipate that people might not be happy about this. So at least you should give them the chance to reconfigure that or make it at least more flexible. And also anticipate that people want to extend your own plugins. So let's say I expose the Docker Java plugin or Docker Java application plugin. Internally at Netflix, they might want to reconfigure certain defaults that I set, and then want to use that as their enterprise version, enterprise flavor of my plugin. So anticipate that, make it easy to extend that. Usually you can do that through plugin composition, but there's also a different way you can make this happen. So I oftentimes actually say, if you don't know for sure if a certain plugin needs to be applied, then rather react to the plugin. So instead of just plain applying it, which makes it highly opinionated, react to it. So how do we react to plugins? So we can say in our plugin logic, if the consuming project applies the IDEA plugin, so it uses the plugin of the type IDEA plugin, then only then please configure the build in a certain kind of way, or my plugin even. So here's one example where we say, well, if the consumer also applies the IDEA plugin, then also run some additional logic. If that person uses the Eclipse plugin or no plugin for IDE integration, then simply ignore that logic. So that's a good way to let logic kick in only under certain conditions. And you can do the same thing for task types. So here we say, well, if the project is a war project, so obviously it creates a web project, then also pre-configure certain things. So these are just some common techniques that I found useful on a high level. And of course, there's far more to be said about like gotchas in plugin development, tips and tricks, and so on. But for this talk, I want to talk about two more topics, testing and documentation, with the main focus on testing, actually. So let's talk about testing. So I mentioned we want to be able to test our plugin on multiple levels. Unit testing, integration testing, functional testing. We probably all know this testing pyramid where we have the right distribution of tests which have a certain impact on your project. I'm not going to drill into that, but just in general, have more unit tests than integration tests and functional tests and work your way up. Because usually integration tests, functional tests are harder to maintain. They might break because they might call off to external components or external services, these kinds of things. So how do you implement each of these test types in Gradle for your plugins? So unit testing, there's really nothing needed from the Gradle core API. So the assumption is you're actually not testing a class which uses the Gradle core API. So totally in isolation as you do with regular unit testing in your application code. So you can simply apply your test framework and then write any assertions that you need. That's really not opinionated at all. Then integration testing is something where I would say we touch usually the API of Gradle. And oftentimes the entry point for this logic is a project instance. So you really want to test something that applies to a project. And for that, we need to create a project. How do you create a project? At the moment, we have this project builder, which is a class in the Gradle core API, which helps you create pretty much almost real-life project instance. We want to improve integration testing in the long run as well, so this is just one step. It's certainly not perfect, but in the meantime, I find it useful to be able to write functional tests. And functional tests, when we talk about that, we want to test the plugin from the end user's perspective. So we want to say if the plugin is applied by this build script and configured in a certain kind of way, and I run this task, then I expect this outcome, or I want this to happen at runtime, or the Gradle build output should indicate certain logging information, these kinds of things, or even want it to fail. So all these assertions can be made. And there are two options right now, I would say. Nebula Test, that's currently an external library developed by Netflix. And we are currently working on Gradle Test Kit, which is going to replace Nebula Test. So again, thank you very much for letting us work on this, sponsoring the work. So thank you very much to Netflix here. So one more thing I want to mention in the context of organizing test logic for plugins. So we usually want to separate physically where certain types of tests sit. I personally don't like categories and these kinds of things. It makes it really hard to filter out certain types of tests that you might write. They shouldn't be all stored in one location if you can. Some build tools actually don't allow you to do that, but in Gradle, pretty easy. So usually what I do is I break it down by unit tests, which is the default test directory, which I have in a Java project, default convention. You could reconfigure that and rename it to unit or something else. Then integration testing and functional testing, they actually sit in a parallel directory here. And you can see for them, I actually use Groovy here. And I also have a directory which I model in my build for any kind of resource files, for example, property files, XML files, and so on. I actually don't want to talk about how to model this very deeply. So in a nutshell, you create a new source set, you point it to that directory, you set the class path, and then you set up a dedicated task for your type of test. And I believe in the long run, we will probably also have support for that in Gradle Core, so you don't have to write this yourself for every project. I believe there are also external plugins that do that, so that might be helpful for you if you don't want to do this yourself. That might help you to set up these test types. So how does a unit test look like in Gradle? Written in Spock. As you can see in the import list, there is no reference to the Gradle API. So in this case, this is just a plain unit test. We have a where clause in Spock where we actually test certain conditions here for certain clauses here or something that we expect. And we just test a plain class, basically, a from instruction. How does it behave at runtime? So no touch point on the Gradle Core API. So let's actually talk about functional testing. Don't want to talk about integration testing because I think this is more interesting because it's also new. Functional testing, as I mentioned, tests the code from the end user's perspective as if you would run the plugin in your own build. And as a plugin developer, I think that's pretty important. It not only serves as testing your build logic, but also as documentation. So later on, when you have a good set of functional tests and somebody asks a question for your plugin, you can simply say, oh, I actually implemented that test case here, have a look at it, this is exactly how you configure it. And what you can do here with the test kit, you basically can execute the build with the tooling API, sends it to the daemon instance, executes the build, and then you get back the output, the outcome of the build. You can check right now the standard output, standard error, then what tasks have been run, were they successful or not, did they fail, skip, update, these kinds of things. And then of course on top of that, whatever your task produces or your plugin can of course be tested as in unit tests. So there's nothing special about that. I think in the beginning I mentioned TestKit came in with 2.6 and I already talked about all of these things, so let's actually have a look how to use that stuff. So first of all, if you wanted to use the test kit, have 2.6. And then the only thing we have to say in our build script, define a dependency on the Gradle test kit. That's a method in the dependency handler, was introduced with 2.6, which adds the API to your project. And we say here test compile. This could actually be something different. The configuration could, for example, say functional test compile, depending on how you actually specify your source set. So that really depends on your setup. This is just in the regular default directory. And then you just pick the testing framework that you want to use. So it's completely test framework agnostic. So we don't tell you you have to use Spock. We don't tell you to use JUnit or something else. You can define what testing framework you want to use. So I think that's kind of convenient. I think in the long run, we will probably write some convenience wrappers around it, or you can even write it yourself. And there's some minimal setup that you also need, but we want to smoothen that out in the upcoming versions of Gradle, that you also will have to tell the Gradle test kit where to find the plugins, the plugin classes, the test test classes under test. So you have to define the class path for running your tests. I'm not going to show this here. You can find it on the documentation page. But just to give you an impression how this could look like, I hope you guys can actually read it. The green doesn't come out properly here. But basically, we take back the Dockerfile task. And you can see, apparently, we created some build file. So this is just a plain file that we created. I'm not showing this here. But we populate it with specific logic. So that's the build file we want to execute. So we just set up a new task of type Dockerfile. We add some instructions from maintainer, these kinds of things. And then we actually want to run this guy. And we run this guy by using the Gradle Runner API. So that's kind of like the entry point added by the test kit. We create a new instance from it. And then we just have to say, point it to the project directory, which has this build file, which we set up in our build, in our test case. And then we can also, like we do on the command line, provide arguments, tasks that we want to run, command line options that we want to add. So you could add info or something else, stuff like that. And then we simply say, build that thing. So what that does, it basically makes the call off to the tooling API, runs the build on the daemon instance, and then gives you back the output of the build. And here I show you one example. So here we can say from the result that we get back, we want to ask for the task. And we ask the task that has been run with a specific path. Again, in this case, just Dockerfile. Give me the output, and the output was successful. So if your build would have failed or your test would have failed when you run this build, actually your test case would have failed as well. And then just one other assertion I make here, was this Dockerfile actually created? And that's independent of the Gradle API. But that's pretty much in a nutshell how you do it. I would encourage you to have a look at the API, and we'll add more stuff to it, just to give you a better impression of what we have done so far and what is going to come up. With 2.6, we introduced the basic mechanics for running these tests, giving you back these results, the build outcome, and you can use that to make assumptions about the outcome of a build. Then with 2.6, which is currently out with RC1, we provide a dedicated test environment in terms of daemons that are just created for running these tests, so they don't use or reuse a daemon that might already exist from when you ran your build as usual as a user. Also, certain things don't kick in, like Gradle.properties in your Gradle user home. That's completely separated. So we want to have a separate, isolated environment just for testing. And also, interestingly, and I know some people ask for it, once the tests are done, please shut down the daemons. So that's happening automatically. With 2.8, I mentioned this in the beginning when we talked about the test kit. The automatic injections of classes under test should happen out of the box. We don't want to bother you with it, so we totally understand this is kind of like inconvenient, but we had to take steps to actually get there. So that's going to come up with 2.8, and then potentially more features in the long run. Debuggability, what else? Matrix testing, these kinds of things. So I have one more section in this talk about documentation. I think this is important, though everybody hates writing documentation, but oh well. Unfortunately, plugins are not self-documenting, and I mentioned before, maybe that's something that sounds kind of interesting to me. If we could ask Gradle, please tell me what this plugin provides me. That could act as automatic self-documenting kind of information. But what do we usually want to document when we talk about plugins? So what's important to the end user? So usually, what does the plugin even do? So what kind of tasks do I get out of the box? How are they pre-configured? How do I reconfigure them, of course? What are the properties and methods exposed? How does the DSL look like if you have one? And what kind of impact does the plugin have on my project? So for example, if you pull in a war plugin from Gradle Core, if you run a sample, all of a sudden you create a war task. You automatically run a war task instead of a jar task. So there are certain impacts on the project that you might introduce with plugins, but you want to tell the user about it. Because oftentimes what I see, if you have a very complex plugin or even a suite of plugins in terms of an enterprise suite that is added to every build across the board, people find this kind of magical. They're like, oh, I don't know what's happening. I have to apply this because my company says that I have to do that. What we want to do by documenting the code is that we want to take away the fear for the end users, for the consumers. We want to demystify the logic that we actually add. We actually want to help them. And we want to give the end users the feeling that they are under control. They know what they're doing. They know how to reconfigure it if it doesn't match their expectations. So what exactly should be documented? I mentioned the purpose of the plugin. Where does it actually come from? Where does it sit? The binary repo, potentially the URL. Then the plugin identifier, the type, the description, bundled in the jar file. For any enhanced task, the name, the type, its task dependencies. And I oftentimes like to also generate Java docs and Groovy docs. Again, we're talking again about regular code, an API that we actually expose to consumers. We can generate Groovy docs and Java docs for our plugins. And we should do this. We should make it public. So I'm doing this for the Docker Java Docker plugin as well. And you can directly basically jump to the custom task. You can have a look at the Java docs or Groovy docs in this case. There's no DSL guide, unfortunately. I would have to put in additional effort to create a nice DSL guide, but it would all be possible. Right now it isn't. Maybe in the long run we add something to like the plugin development plugin in Gradle Core. The DSL, important. How can I configure it? What is the nesting level? What kind of elements do I deal with? Some examples in textual form, just to get people started. I think that's always helpful. If people go to plugin pages, they like to copy paste something just to see how it works, to get started. And then a good set of functional tests, so you can demonstrate basically certain use cases that you might foresee, that you might even write as a plugin developer. So that's what I wanted to talk about in terms of documentation. This is the last slide. Other aspects, when you're writing plugins, be mindful of the potential performance impact that you might have on the consuming project. So if you make HTTP calls with every time that you apply the plugin, that's obviously bad. And at some point of time you ask yourself, why is my build slow? I have no idea. So you have to go into profiling. Your plugin doesn't tell the consumer why this is happening. So you just inherited that somehow. So try to be mindful, think about why you need to run certain operations and try to run them once potentially to initialize them. Try to avoid the internal Gradle API as you go, as you upgrade to newer versions, or if your consumers upgrade to newer versions, that might actually break your plugin. So the less internal APIs you use, the better. We're aware of the fact that sometimes if you want to do more complex kind of things, you might have to go to internal APIs, which is fine. It's not forbidden, but just keep in mind that it might actually break your plugin in future versions. So that's here we can actually pin it back to the need of wanting to test your plugins also against multiple versions. So some cross-version testing would be useful, and that would potentially be moved into Gradle TestKit as well. And then, as with other application code, set up CI. Don't want to talk about that. And if you can, share it with other people. Publish it to the plugin portal that we have for easier consumption, for discovery. In the long run, we'll probably also let you vote plugins, I guess, and other things, social features. And there are many more aspects that we could talk about, but that's pretty much what I wanted to cover in my 45 minutes. Unfortunately, no demos next time in the bigger talk, but that's all I had for today. So hopefully that was kind of interesting to get some insight in what I learned, even though there are no demos. But you can have a look at that specific plugin and see how I structured code that might give you an idea on how to approach your own plugin development. All right, any questions? There are still t-shirts.
Does Gradle plan breaking things?
Yeah, so the question is, as plugin as Gradle Core or developers in Gradle Core, are we aware of the fact that people are using internal APIs, and do we want to promote them into public APIs? Yes. I would recommend opening a discussion on the Gradle forum about what you're trying to do. Maybe there's already a public way that you don't know about that lets you do these kinds of things. Of course, this will take a while, and we might not have the bandwidth to expose it right away as public API, but that would basically be the idea. Have the right abstraction for the public API instead of like using internal stuff. But yeah, we are aware of that. My recommendation would be raise it either on the Gradle dev list or the Gradle forum. So the question is, how do I instantiate file collections and file trees? Or?
Well, there's certain interfaces, for example, file collection. If you try to implement it in current Gradle anyway, it will be a non-starter because of reflection.
Do you have a specific use case, maybe?
I
Like,
can take it offline with
okay, yeah. Let's talk about it.
It sounds like you're not aware of that.
Yeah, usually like there are some methods, maybe potentially through some other factory class or something else that allows you to create an instance of something else without having to basically instantiate the default implementation of that interface. Depends on the use case. We can talk about it.
Find bugs or something?
At the moment, there isn't. I'm not aware of. It's a cool idea if you want to contribute. I think that would be actually a nice contribution for the plugin development plugin, which allows you to basically write your own plugin code. So if you would have a task in the end that would say, well, check whatever I've written and see if you find potential issues with it that we think are bad or not, or with potentially even different versions of Gradle, that would be pretty cool, I think. People would find that helpful. Yep.
Yeah. Or is it not like good practice, I would say?
That's kind of like a wide question, I guess. Hans, do you have some official answer? Or? I mean, generally speaking.
Can you repeat the question first?
So the question is.
Maybe I'll rephrase the question.
No, I understood the question, maybe just for the audio.
So with all the plugins that we have, for example, Docker, which kind of like is used within the context of continuous delivery, is there kind of something, an overarching concept tool that we're planning to implement or provide, or some general high-level idea that ties it all together? Is that kind of like the question?
Or is it a good practice to actually consider using Gradle as a continuous
Okay.
Delivery tool instead of other ones like?
Okay, so the question is it a good practice to use Gradle for the whole pipeline of a continuous delivery process?
Thanks.
Right, cool. Thank you.